Okay, this is MCT4C Day 2, Lesson 1.1. The 3-minute review goal is to use Pythagorean theorem to find unknown sides in a right triangle. So this is thinking way back to grade 9 and before, using Pythagorean theorem. Remember, in the Pythagorean theorem, H is the hypotenuse. It goes on the one side by itself, and the other two sides are the not hypotenuse. Okay, so in this one, if we wanted to find x is the hypotenuse. Remember, 90 degrees points at it, so we'll find the and then x squared, 1 plus 1 is 2. Find x by taking the square root of both sides. And in fact, we're going to leave that as square root of 2 instead of getting a decimal answer, and we'll see why soon. And the second one, the hypotenuse is the 2-inch side, so we got 2 squared is 1 squared plus x squared, and we want to find x, so we'll figure this stuff out. Subtract 1 from both sides, square root, and x is the square root of 3. And again, we're going to leave this as a root. This is a perfect number. And we're going to leave it there for a reason why we'll see soon. Okay, that's it for the 3-minute review, and on to the lesson. So here it says 1.1a. Usually when it says 1.1a, there's a b, but I think what happened here was I was going to split it into 2 days, but this is just going to be one fairly long lesson, so strap yourself in. This might be a little while. The expectations today is to determine the exact values of trig ratios of 0, 30, 45, 60, and 90, and their multiples. So the key word there is exact. These are ones we're not using a calculator, we're not, looking up stuff in tables or getting decimal values. These are going to be exact, and so that's why we had square roots before. So really, these were the 2 triangles here that we found in the 3-minute review, and so these are 2 special triangles, and we can write the trig ratios, and we will in a second, that go along with them. What's so special about these, before we get too far, hopefully you've seen these shapes before, maybe in drafting, or you bought a math set and you see these triangles. There's the 45, 45, 90. This one's the 60, 30, 90 triangle. It's used in drafting, old drafting set here, and you can see in any drafting drawings, these angles are used a lot. There's a 60 or 2 60s. There's 30-degree angle there. Probably some 45s in here somewhere. But these angles are used a lot. Essentially, it was back in the day to make calculations easier if you knew how to do it exact, because there weren't calculators, right? So whenever you needed to do trig ratios, for instance, the cosine of 15 degrees, well, you'd look it up in a table like this, then you'd have to deal with decimal approximations, and multiplying by 4-digit decimals is no fun, because remember, we didn't have a calculator then, so all of this was done longhand. It was no fun. A number like these trig ratios that we'll find, exact ratios like 1 over the square root of 2, like we'll see, and square root of 3 over 2, these are pretty good, easy to deal with, rather than these decimals, and so we're kind of stuck with learning these ratios exactly. Another spot where it comes in, and this is not till next unit, but when we talk about these trig functions, and we did this last year in grade 11, but these exact trig ratios will help us draw good trig functions, better trig functions than if we use the decimals all the time. So hopefully that you'll buy that motivation of why we would want to know these exactly. Okay, it is part of the course, so if you're not buying that, well, suck it up anyway. So there. And I'm just going to go through and list them off here. We've got sine of 30. Remember SOHCAHTOA. Sine of 30 degrees is opposite over hypotenuse. It's a half. Cos of 30 adjacent over hypotenuse, square root of 3 over 2. And I'm just reading this straight off of there. Tangent of 30 opposite over adjacent. Here, now our reference angle is 60. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. And there's some patterns going on here, and we'll see how this sort of fits in soon. The 45 one maybe is easier to remember. Sine of 45, we take either one of these, I guess. Let's take that one. Opposite over hypotenuse, 1 over the square root of 2. Cos is adjacent over hypotenuse, 1 over square root of 2. Again, they're the same, which kind of makes sense since the angles are the same, that the cosine and sine would be the same as well. Tangent, opposite over adjacent, is just 1. 1 divided by 1 is 1. And the next thing that I'm going to do is I'm going to collect these up in a table, just so we can see them and hopefully maybe see a pattern. And there's that slide that I was talking about before. So here's this table, and for now, we're going to use our calculator, fill in the entries for 0 and 90 degrees. So grab your calculator, sine of 0, so put in 0 and hit sine, we get that at 0. And then if I look back on the work we did earlier, I can just fill in these. This is straight from the last slide. I'm just copying it. Now, the sine of 90, grab a calculator, hit 90 sine, you get 1. And what's weird about this one, the cosine is just the opposite. So it's kind of like if we started here and read this way, we'd get the cosine. So these values are actually not that hard to remember because they're such a nice pattern. Cos of 90, fire it into a calculator, is 0. And the tangent, then if I use my calculator, tan of 0 is 0. Tan of 30 is 1 over the square root of 2. We wrote that on earlier. That's 1. Square root of 3 over 2. Oops, sorry. Square root of 3 over 1, or just the square root of 3, isn't it? And this one is actually, you get an error. Or it's undefined. And that's kind of weird. But these values, we actually need to remember them. So, you can either remember these triangles and come up with the sine and the cosine of each of these from these triangles, or I'll go through a way that I like real quick here, okay? And essentially what we're going to do is memorize this entire table. Well, sort of. Here's what we do. We've got to remember how to set it up. Sine, cos, and tan. And then 0, 30, 45, 60, and 90. Okay, and I'm trying not to look up here. I know that because I just have to remember this. Sine starts at 0 and ends at 1. Start and end. Halfway between is a half, right? Halfway between 0 and 1 is a half. Halfway between 0 and a half is a quarter, isn't it? Halfway between a half and 1 is 3/4. Say, well, rest all these aren't the numbers. It doesn't match. What are you doing? You're just confusing me. Well, now if we take the square root of everything here, we get the numbers we want. Square root of 0 is 0. The square root of a quarter, square root of 1 is 1. The square root of 4 is 2. Square root of 1 is 1. Square root of 2 is the square root of 2. Square root of 3 is the square root of 3. Square root of 4 is 2. Square root of 1 is 1. And so then these red numbers are our actual numbers. And of course, cosine is the other way, isn't it? It just goes the other way. So I can just go 1 square root of 3 over 2. 1 over the square root of 2, a half, and 0. And then tangent is a weird one. Essentially, tangent is the sine divided by the cos. So if I go 0 divided by 1, I can get tan. If I go 1/2 divided by the square root of 3 over 2, well, essentially the 2's will cancel out, and then I'm just left with the numbers. Well, anything divided by self is just 1. Square root of 3 divided by 1 is the square root of 3. 2's cancel out when you divide. And 1 divided by 0, well, that's when you get your error, right? So this is how I remember the exact trig ratios. And it's a little bit tough to remember, I suppose, but if you can remember how to get these tables, you'll never forget what these numbers are, okay? Let me have a look at my time here and see if I'm close to 10 minutes. I am. I'm going to stop there, and we'll pick up the examples in just the second video for today.